So I haven't posted here in a little while. Part of that was I wanted to a little bit of research into Unreal Engine and the Godot engine, and this kind of came after all the news and the fiasco related to Unity. Unity has done this kind of multiple times, third time's the charm essentially for me. So I ended up doing some research into things that I really liked about Godot and things that I really liked about the Unreal Engine. One thing that I really came across with in the Unreal Engine was something called procedural content generation. And procedural content generation is basically just a way to dynamically spawn things like game objects and stuff like that into your scene. They don't really call it game objects in Unreal, but in the Unity world, we're going to call it game objects. So I liked that a lot. So I decided to actually bring that over into the Unity engine. So that's actually what I wanted to talk to you a little bit today about is I took that little bit of a break and decided to build a brand new tool called procedural content generation inside of Unity. And so I'm going to show that off just a little bit here. If we go to 3D object, PCG, I'm going to start off with volume. And so this is the procedural content generation volume. And what this is going to allow you to do is to essentially generate objects within this specified space. So this whole system actually was pretty complicated. It took a lot more linear algebra than I thought it would take. Which surprised me quite a bit. Math. It ended up being quite complex. So I'm not going to go into each individual setting and all of this. I'm going to have more tutorial videos on that. Let's just talk about kind of how this was made. I'm going to click debug here, generate, just so we can have something to talk about. It basically has the ability to follow the curvature of any object, spawn it on that, or you can spawn it straight up and down. So if I click here, and I do always up, generate, you'll see that it generates it up. But for the sake of, I want to show you what I'm talking about, I'm going to generate it as following this curvature here. It also has the ability to allow certain angles. You'll see that this part right here is, it's too steep. So it's not spawning objects within that. You can offset it, you can rotate off it, you can scale it, min and max values. You can allow mesh overlap. You'll see right here, none of these meshes are actually touching each other because I'm not allowing meshes to overlap. So if I say allow mesh overlap, you'll see now meshes are, overlapping here. So, just depending on how you want to spawn certain objects. Now, again, this is within debug mode here. So if I was to do it with something in real time, we can come over here to PCG settings. I have this already set up. Basically, if we were to look at this, everything you see here are settings for this individual object to be spawned. All of this is coming from nature manufacturer assets here, but that's beside the point. You can set that up however you want. And so I'm going to click generate. This is going to take about a minute for it to run, so I'm just going to do that. We'll come back.
Wait.
And I wish I actually would have expanded this here, because you'll see it'll dynamically start populating all of this as it goes down. But the whole process takes about a minute, and when it's done, you're going to have a complete fleshed out forest scene. And all it took was setting up a few settings and tweaking that to your liking and clicking generate, and that's where the debug it really comes into play here. Oh, perfect. So it's populating it here now. We can kind of see that happen in real time as it goes. It's generating all the plants, and there we go. It is now done. And when it's done, you now have yourself a forest according to the settings that you have specified. And again, those angles, certain things are not spawning at those angles, and it's all within this volume here that I have set, basically this little cube. I click clear here, it's gonna delete all those objects, and I can run through it again if I want to. All right, so one of the first hurdles that I really had with generating something like this was, it's a very simple concept, but allow mesh overlap. So think about it. How would you do this? Well, the first thought would be, well, okay, let's just collider on here and let's check if things collide with each other. Well, whoopsie, that actually doesn't work in an editor. The physics system, other than raycasting, actually never runs inside of an editor. So if I was to do a collision check with editor scripts, it would never work. And that was the first problem I came across, is I could actually not use convex mesh colliders, box colliders, things like that, because the collision system, that physics system, does not run inside of the editor. So one thing I actually had to do was take a concept called bounds. Using a mesh bounds, they actually have something inside that bounds class provided by Unity called intersects. And you could say one bound intersects with another, and basically I would spawn an object. I would check, hey, does this bound interact with this other bound? If the answer is yes, then I would destroy that object. And now when I did that, it actually generated a ton of garbage inside of Unity. So spawning a game object inside of Unity is very garbage intensive. And for anybody that's had experience with that, you understand garbage is kind of the major problem when it comes to Unity. It just generates so much. And so slowed down things like significantly. Instead of waiting what I just showed you there, which is about a minute, I would be waiting upwards of 5 minutes as it would generate objects and then destroy them again, or vice versa. So what I ended up doing is, instead of spawning the object, I actually knew the size of the object because I had a reference to that mesh already. So I didn't actually have to physically spawn that object. The problem became is I no longer could use bounds with it because there was no physical object to compare with something else. It hadn't physically been spawned yet. So luckily I found GitHub repo. I basically found this. It's the decompilation of the Unity engine uploaded on GitHub here. But one thing you'll notice is here, intersect. And it's just this simple function here. So I was able to rewrite that, and actually, because I was able to write my own, I could then put it inside of a thread, and I could start multi-threading things and speeding things up significantly. And that really helped with speeding things up by not spawning things and multi-threading them, and basically writing my own functions this way to compare mesh states with each other. And then the amount is pretty self-explanatory. Angle is self-explanatory. I just said, hey, compare when I hit this, I see the normal. What is the vector 3 angle offset from up to the normal? And if that's greater than this angle amount, then I'm going to skip spawning this object. So basically all these checks would happen before I would spawn an object, and that means no garbage. I no longer have to worry about this massive amount of garbage being generated in order for me to just spawn an object. So that was huge. That saved me a bunch of time. So now the other hard one, which is that was okay. I mean, there were some difficulties there, learning about finding out what the intersect function does, using meshes and raycasting and avoiding colliders. But it got to a whole other game once I started using splines. So here it's just a spline object. And what I'm going to do here is I'm going to generate a spline path. So I'm going to set a couple of points here. And we're going to turn on debugging. We're going to generate, and you'll see it does that generation process at the same as the volume, but now it's along a path. And you would think, oh, that's no big deal. It was a big deal. It took so much more work because these boxes, they're no longer uniform. It's no longer a box. It's a rectangle, or it could be a box, So now I had to dynamically calculate the size of this volume that I would have to spawn things into. And in order to create things nice visually, see this little connection here? That was such a nightmare to figure out because I had to, there's no function inside of Unity to generate these gizmos. I had to calculate each individual one of these points here and you have to calculate it basically as a quad. So each one of these quads I fill up and generate a box for you to create a nice visual element. And then I had to combine that with the ability to change the width and change the height. And that took a few hours to figure out properly. That was a bit of a nightmare. And then generating it, once I figured out the bounds, it's honestly not too bad, right? I'm using all the same exact functionality of the volume inside of the spline, but now I'm just doing it in terms of these 2 points, these 2 points, and these 2 points. You don't think of it as a whole. And then you calculate it individually. And then the other thing that happens is this amount, I now have to divide it by these paths here. And I have to, since there's 3 sections, I divide this by 3, and then that's how many points I'm going to select and attempt to spawn in each of these to try and even out this amount across the whole spline. It ended up working out pretty well, and as you can see here, generating it is just super fast. It works out really well. And then I can also use all the same settings as I did before: up, angle, amount, scaling, a mesh. I didn't talk about destroy other meshes, but basically if this is spawned and another mesh and it touches that other mesh, it will destroy that other mesh, using the same concept as allow mesh overlap, that bounds functionality there. However, because these were, let's do straight line here so you can get a better idea. Because these aren't uniform boxes, one thing that I had an issue here was what happens if I want to destroy things. So now I gave the ability to say, hey, on the spline path, anything that is touching the spline path will be deleted. So this is a great example. If I had generated this forest, I can put a spline path through the forest to delete objects to generate like a walking path or something like that. So I could delete those objects and then regenerate this with like rocks and gravel and things like that to generate that walkway. To destroy that, how do you calculate? So if I click cube here and put it, and actually let's do always on Gizmo, and so this is touching, right? We're barely touching there. This one is not touching, right? So how would I figure that out, right? Because you can't use physics here. You can't use convex or mesh, and you can't use bounds because bounds calculates like a uniform box essentially around something, and this is a non-uniform. So, and because you're having to calculate these individual sections. So I found after a lot of research, the easiest thing to do is I know what the maximum left, maximum right, maximum up, maximum down is off the center line. And you can calculate those distances, right? So if you know the object here, you can say this object is of a greater distance than this height here, so I'm not going to delete it. Whereas this object is just barely within that distance value because of this face. Now, this is where the extreme complexity comes into play. You can't use bounds here because bounds.intersect doesn't work with a scenario like this. So you end up having to calculate the closest face to this line. And you would think, oh, that's pretty easy. Unity has no built-in way to do this inside of the editor, which means I had to figure it out and do it myself. Basically, it calculates and finds each individual point and triangle and finds the closest triangle face to this individual object and does it super, super fast. See, if I click destroy, it does it super, super fast. That was extremely difficult to do, simply calculating the closest face to a point. The other way you calculate, all right, well, what is the closest point on the line? Is it this one? Is it this one? Is it this one? The answer is you would actually use a function called vector3 project. So project is the concept of here is this line. I'm trying to find the closest point on this line that this object is to. Here's my starting point. Project will say, I'm going to draw a line from here to here, and a line from here to my other point, and then I'm going to do a 90-degree angle from this down to this, and that's going to be my closest point. And that's basically what vector3 project does, and luckily Unity already had a built-in function for this, which saved my bacon, and that was super, super nice. So that's kind of a highlight as an overview to what I have been working on. is the ability to dynamically generate things along a path or in a volume and to quickly build out a scene for you. If you want it, it's actually available on my Patreon right now. It's available to the premium members, probably release it to the lower grade members after a couple weeks. Then after that, I'll go ahead and release it on the asset store and the Gumroad store for anybody that's interested.